Hello, and welcome to your while loops lecture. So in the past two lectures, we've been talking a lot about if and if else and if else statements, which check a Boolean condition and then use that to decide whether or not to run a suite of code. And that's been incredibly useful so far. But what if we want to check a Boolean condition multiple times? For instance, you know those nights when you lay tossing and turning and you wake up every 30 minutes and you check your phone and see whether it's early enough to get out of bed? Well, you're not just checking one time. You're going to check over and over until it is early enough to get out of bed, and then you'll get out of bed and start your day. Well, the if statement would have a tiny problem with that because it would only check your Boolean condition, is it early enough to get up, one time. We want something that can check over and over and over until some type of condition is satisfied. One example would be if you wrote an alarm clock app in Python, where you checked periodically what time it was and whether it was time for the alarm to go off. When it was, the alarm would go off and you would be finished. Otherwise, you would keep checking the time every so often. Well, while an if statement can't handle this, something new that we're about to learn, the while loop, can. A while loop is very similar to an if statement because it still checks whether a Boolean is true or false and chooses whether to execute code based on that true or false value. Similarly to the if statement, a while loop will only execute if the Boolean is true. However, the difference with a while loop is if the Boolean is true and our while suite executes, it will check again whether the condition is still true, run again, until finally, if the condition is false, it'll exit the loop and be done. This is different because that means that we're checking the condition over and over and over, and we're only finishing once the condition is false. The syntax for a while loop looks a lot like an if statement. Instead of if, though, we'll say while, and then a Boolean expression which will either be true, in which case the suite of code under the while will run, otherwise we won't run any of it. Let's go ahead and go to Atom and look at an example. So in the past, we could have had a variable like x equals -6, and we could say if x less than 0, print your number is negative. But again, the limitation here is that your if statement is only going to check this condition one time. Say we wanted to keep checking our number and stop only once we found a number that is not negative. We could say while x is less than 0, print your number is negative. And then we could increment x by, say, 1. X plus equals 1. Then remember, because this was originally true, we would run the while suite and then check again. And then check again and again until this statement is finally false. In our case, -6 would be true, so this would run. Then would add 1, so we'd be -5. This is true again, so this would run. It would go up by 1, so -4. Again, this is true. -3, true. -2, true. -1, true. And finally, we would get to 0, which is the first time that this while loop will evaluate to false because x is equal to 0, not less than 0. So this while loop would continue checking for us every single time, unlike the if statement, which only checks once. Let's go ahead and run this and see what the output of our code is. I'm also going to add a print statement here, which says print x, just so we can keep track of what x is in this case. All right, I'm going to go ahead and go to Platformio, New Terminal, and I'm going to check that this is the folder that my code is in. It's actually not, so I'm going to move to it, and now we're ready to run our code. I'm going to say Python while loops 7 blank.py. All right, so this is going to execute the if statement and then the while statement, and let's look at how they're different. All right, let's increase this so we can see all of the output. So when we had an if statement, x was -6, and we just printed out your number is negative because it only checked once and it was indeed negative. When we ran our while loop instead, we first printed out your number is negative as with the if statement, but then we added 1, we printed out the number, now it's -5, and our while loop checked the condition again. It was again negative, added 1, -4, true, negative, etc. It went on and on, checking the condition over and over until finally our number was no longer negative. It was 0. And that is when the while loop stopped, because this expression finally evaluated to false. So remember, if statements will check something once, while statements will check over and over and over again, and we'll just keep on checking until the condition that it's checking finally evaluates to false. Now, you might be asking, what if the condition the while loop is checking is never true? We keep saying that it'll check over and over until it's false, but what if it's false to begin with? Well, just like an if statement, then the while loop will never run. Now, you might be asking, what happens if the while is always true? What if it could never ever be false? Remember, our while loop will keep checking until the condition is false, and if it's not possible for that condition to be false, then the while loop will keep checking forever and ever. Let's go to Atom and see some examples of both of these things. All right, let's go ahead and have a variable called x and set it equal to 10. Then we'll have a while loop which checks whether x is less than 0. If it is, we'll print your number is negative, just as before. And then we'll go ahead and print adding 1, x is now, and then we'll print x. So then we should probably actually increment x in there, x plus equals 1. So you can see that this is similar to the code we ran before, but now we're starting out with a number 10, which is not less than 0, and adding 1 to 10 will never make it less than 0. So let's see what our while loop does. All right, let's go ahead and run our code, and nothing outputs, which makes sense. If x is 10, this is false to begin with, and our while loop never checks again. Remember, once the while loop is false, it stops. It's never checking anything again, it's done, and that's exactly what happened here. All right, let's go ahead and copy and paste our code from last time. But this time, let's go ahead and comment out these 2 lines that say we're adding 1 and that actually add 1 to x. Now, let's think through this for a second before we run our code. X is equal currently to negative 10. And we're checking in our while loop, is x less than 0? Well, yes it is. We print out your number is negative, and then print out the actual number. And then our while loop is going to check our condition again. It's going to say, well, is x less than 0? Yes, it still is, because we didn't change it. And so this condition here can never ever be false, because we're never changing x, and x is negative to begin with, so this while loop will run forever. And don't do this if you don't have to, because obviously it's literally going to run forever, but let me show you what happens when you run code like this. So we'll go ahead and run, and this is going to go on forever. We have created what's called an infinite loop, because it's literally impossible for this loop to exit on its own, because we've never changed anything about our variables that could possibly make our condition that we're checking false. We want to avoid infinite loops whenever possible, because obviously it's just going to keep printing out this forever. This is why it's super important to increment your variables or change something about the statement that your while loop is checking so that you don't create an infinite loop that can never be false. So just like with an if statement, you want to make sure that you have some code in your while suite, but also it's really important to make sure you're changing something so that this condition here that you're checking can at least in theory be false eventually. Now, if you ever have a while loop that's infinite and is running like this, you're gonna have to kill it. So I'm gonna go ahead and close out this terminal process so that my infinite loop can finally stop. So let's go over the parts of a while loop. First, we have an initialization. This is something that allows you to check the condition in your while loop. For instance, here we've set x equal to 0. Next, we have our control, which means how do we decide when our loop is going to run? This is determined by the Boolean statement that we're checking with our while loop. When should it run? Well, when this Boolean expression is true. When should it stop running? When that Boolean expression is false. And finally, we need to have some type of iteration or modification so that the condition that we're checking is, at least in theory, false eventually. Otherwise, we get an infinite loop and your loop will just keep doing what it's doing forever and your computer will never get a break. In this while loop that I have, the initialization happens here where I'm setting up parameters to be able to check a condition. The control happens right here where we have a Boolean expression that we'd like to check and which will determine whether or not we run the while sweep. And finally here, the most important part, we have a modification or an iteration which changes the value of x, which is part of our Boolean expression, so that eventually our while loop can be false and stop running. All right, let's learn a little bit about a Sentinel loop. Now, a Sentinel loop is basically a way to use a while loop where you have a certain variable here called condition unsatisfied that you set equal to true or false. This variable serves as a sentinel or a guard for your loop that tells it when it can stop. Instead of having some kind of Boolean operator in the while loop like x is less than 10, we instead just have this variable that is set equal to true in the beginning and then is changed within the while loop. This can be really useful when there's not a particular single or simple Boolean comparison that you'll be able to loop on. Rather, maybe there's something more complicated that you want to do and you just want to have a value that keeps track of whether or not your conditions have been satisfied. When the conditions have been satisfied, you set your Sentinel condition unsatisfied to false, and that will stop your while loop from running because we're saying while condition unsatisfied, and as soon as that's false, we're going to go ahead and stop our while loop. I think these are a little bit easier to understand when you see some code, so let's work through some. Okay, let's build up to our Sentinel loop. First, let's do a simple example of a password checker. We're going to say password equals input, what's your password? Beautiful. And then we are going to use a while loop to keep prompting the user for their password if they type it incorrectly. So we'll say while password is not equal to whatever we think their password should be. In this case, we'll say the best password ever 230. So while the password they entered is not equal to the password that we have in store for them, we are going to say print that is not correct. And then we are going to copy and paste this because we're going to ask them to re-enter their password. And this is really useful because until they enter the right password, we will never stop looping and asking them for their password. We don't want to accidentally let them into a website when they type the wrong password. All right, let's go ahead and test this out. So when we go ahead and run something, let's put in a password. Let's say 123 password. Now this is not equal to the best password ever 230, so it shouldn't let us in. And in fact, it does not. It says that's not correct. What's your password? I'm going to put Chelsea. Oh, that's also not correct. What's your password? Yellow. Not correct again. All right. It's going to keep asking me for my password until I finally put the correct one in. So let's go ahead and do that. The best password ever 230. Enter. Okay. Finally, our while loop stopped. Why? Because password was finally equal to the best password ever 230. All right, so I've gone ahead and copy and pasted our code from the last problem, but let's add some functionality here. Often, websites will limit the number of guesses you can make on your password in order to prevent hackers from trying infinite possibilities and potentially hacking your account. So instead of letting people guess forever what their password is, let's say we want to limit them to 3 tries. So we need to add some variables. First, let's add something for the guess limit, which is how many guesses we're going to allow them to make. Next, let's have a variable called guesses and set it equal to 1, because after they've been asked one time, they've made a single guess. Okay, so here's our while loop, and this looks exactly like it did before, but now we have to add the functionality of limiting the number of guesses that they have. So instead of our loop running when they haven't guessed the correct password, we want it to run only if they haven't guessed the correct password and they haven't exceeded the number of guesses that they're allowed to make. So we want to say while password is not equal to the correct password and guesses is less than guess limit. This is basically saying I want you to stop the while loop if they've correctly entered their password or if they've exceeded the number of guesses that they're allowed to make. I'm going to save that. Now, this part is still correct. If they don't put in the correct password, we would like to prompt them for a new one. But we now have to increment guesses because as we make a new guess, we want to increment the number of guesses they've made so that we can stop once they've made 3. So I'm going to say guesses plus equals 1. So let's go ahead and run this. We're going to say Python 3 while loops blank. All right. So what's your password? How about mouse? That's not correct. How about pencil? Also not correct. How about curtain? Also not correct. And the program has not let me in because I've exceeded the 3 guesses that I was allowed to make. So you can see we learned and or when we were talking about if statements, but we can also use them in while loops. All right, let's finally get to that Sentinel loop. And this time, instead of asking someone to enter their password to get into a website, let's help someone set their password. All right, so let's set up our Sentinel. We'll say PW not found equals true. So this variable is going to be true as long as we've not found a suitable password for this person. Then we're going to go ahead and ask the person to enter a password. We're going to say PW equals input. Please set a new password. Beautiful. Okay, so now we're going to use our Sentinel to loop on. So we're going to say while PW not found. And then this is basically going to be the guard to whether or not our loop is going to keep running. Until we change the variable PW not found to false, this loop is going to keep running. So we do have to remember to change it. But let's think a little bit about what we're checking. Let's say that the conditions for having a good password are that it is not your old password and it is longer than 10 characters. We can check that using an if statement. We'll say if PW is not equal to our old password. Let's say our old password is this is my old password 123 and len of password is greater than 10, so if it's longer than 10 characters, if both those conditions are satisfied, it's not their old password and it's longer than 10 characters, we're going to say, okay, that's a suitable password. And we're going to set PW not found equal to false. This will cause our while loop to exit because the condition, this variable, is now false. However, if either of those conditions are not met, we're going to want them to re-enter a new potential password. So we're going to say else, and we're going to copy and paste this, and we're going to say print that's a bad password, and then ask them for a new one. All right, let's go ahead and save, and let's comment out the old code that we had and go ahead and run this. So let's choose a password. All right, let's set a new password. First, I'm going to try my old password because that always happens. We're going to say this is my old password 123. Oh, it's saying that's a bad password. Okay, how about mouse? That's a bad password too. That one, not because it's the same as our old password, but because it's too short. Let's just try one that's too short again. We'll say egg. Ugh, that's too short. Okay, let's do another long one. I love CPSC 230 with all my heart. 1, 2, 3, 4. Beautiful. Finally, our while loop exited, and that's because we finally had a password that satisfied both these conditions, and our Sentinel variable, PW not found, was set equal to false. You can see how this is a little different from the while loops that we've done before, where we're explicitly checking a condition. Instead, here we have a single variable that's kind of guarding our loop, and in the course of our while suite, we change that to false whenever we want the while loop to be done running. All right, the last two things I want to talk about are break and continue. These are tools that we can use inside of our loops, and actually we can use them in for loops as well, so we'll come back to them when we learn about for loops. But for now, we'll talk about how you can use break and continue inside of a while loop. First, let's talk about break. Break is a way to immediately exit your current loop. It basically stops everything in its track and skips any code that's after it, and it's basically like an emergency exit for your loop. For instance, if you want to exit a loop because something's gone wrong or because you've satisfied all your conditions and you don't want to run anything anymore, you can use a break statement. Let's see how one looks in Atom. All right, let's go ahead and code up a game where we're having someone try and guess a number that we've thought of between 0 and 100. So first, let's ask them for their guess. We're going to say guess equals int input guess. And we're turning this into an integer because we know that they're guessing numbers and we'd like to turn it into a number because input comes into us as a string. All right, so we know that they have to guess something between 0 and 100. Well, let's go ahead and loop on that because if they guess something outside of our range, they're probably not paying attention and we don't want to play our game with them. So we'll say while guess is less than 100, actually we'll say less than or equal to 100, and guess is greater than or equal to 0, so that means it's between 0 and 100, then we can go ahead and have our game. Well, we probably have a number that we need to guess, so let's say number equals 7 for now. Okay, say that we're very nice and we want to give them some hints. So we say if guess is less than number, so if their guess is too low, we will print too low. Else, if their guess is too high, so their guess is greater than our number, we'll print too high. Now, if their guess isn't too low, nor is it too high, it is probably correct. So we're going to say else print right. Now, if they've guessed the correct number, the game is over. We don't have to ask them for any more guesses. We don't have to check any more numbers. We just end the game. And so here is where we're going to use our break statement. We're going to put break right here. And remember, break is like an emergency exit. Once we come to the break statement in our code, the while loop is never going to evaluate again, and none of the code below this break statement will run either. So for instance, just to test it out, let's say print good job. All right, now let's say that they're not correct. Well, then we need to get another guess from them. So I'm going to copy and paste this guess code right here and paste it here. So if they weren't correct, then we need to get another guess from them. Last but not least, I'm going to add an else statement that goes with our while statement. And this is going to basically say print you quit. Because this is saying if you guess a number outside of our range, well, then you've quit the game and I win. All right, let's go ahead and play our game. All right, so let's make a guess. Well, we know what the number is, but let's guess 10. Okay, our game is telling us that we are too high. How about 9? Still too high. All right, let's jump all the way down to 3. Now we're too low. All right, we know it's between 3 and 9. Let's guess 7. Beautiful, so it prints right and then it stops. We've guessed the correct thing, so there's no need to do anything else. Notice, the break statement is a hard exit. As soon as we hit it, no other code will be run. The while loop will not check the condition again. So you can see that even though we had this print statement to say print good job, it didn't run because as soon as it sees the break, Python is done. It will not run any more code. All right, let's just check what would happen if we guess something outside of our range. So I'm going to go ahead and rerun this and guess 109. I quit. So you can see that if this is false, the else statement that goes with our while loop will run, and it did tell us that we've quit because we broke the rules and guessed a number outside of 0 to 100. All right, last we will talk about continue. Continue is sort of like a less extreme version of break. Continue immediately exits from one iteration of the loop, but it allows the while loop to check the next iteration. So a continue will mean that we aren't going to run any of the code below the continue, but we will go ahead and check one more time whether the condition is true or not. Let's go to Atom to see an example. All right, let's go ahead and write some code to figure out what the sum of all of the odd numbers less than 10 is. We'll start out with a variable I equal to 0, and then we'll say while I is less than 10, and then let's go ahead and check if our number is odd or not. Well, we know how to check if a number is even, so we'll say if I modulo 2 equals 0. If it is, it's even. Continue. This is basically saying if the number is even, go ahead and move on. We don't need to include it here because we're just finding the sum of all of the odd numbers. Although remember, it's very important to still increment I because we need to make sure that every time that we're doing our while loop that the condition is changing. Otherwise, we could end up with an infinite loop. So I'm going to say if I modulo 2 is 0, I plus equals 1, continue because we don't need to add it to our sum. So if it's not even, we do want to add it to our sum. So let's take a variable and we'll call it odds sum equals 0. That'll be where we keep the running total of our sum of odds numbers. So if it's odd, we're going to say odds sum plus equals I. And then of course we still have to increment I. So we'll say I plus equals 1. Then let's go ahead and print the current total. So we'll say current sum plus odds sum. And of course, once we're done with our entire loop, once it's looped through all the numbers less than 10, let's go ahead and print out sum plus, turn it into a string, odds sum. Beautiful. All right, let's go ahead and run our code. All right, so we started out with 0, and then we added 1. We skipped 2. We added 3. We skipped 4. We added 5. We skipped 6. We added 7. We skipped 8. We added 9. And then we were done with all of the numbers that we were looking at. And then we got that our total sum was 25. So all of the odd numbers between 0 and 10, their sum is 25. Now, notice that all of this stuff didn't run for any of the even numbers. That's because, like the break, the continue will not run any code below it. However, unlike the break, we did continue with our while loop iterations. This is because, again, the continue is sort of a softer version of break where it stops the current iteration of the loop, but it allows a next iteration, allowing us to only run all of this code when we hit an odd number. We'll talk a little bit more about continue statements, especially when we get to for loops, but for now, this is how you use break and continue with a while loop. All right, that is all I have for you. I will see you guys next time.